So this might be a record day. We might get 3 units done, 3 lessons done in one day, but we'll see. We've been learning throughout this entire unit that 3 words are equivalent, and that is that the zeros of the function are equal to the x-intercepts of the graph, which equals the roots of the corresponding equation. They are all the same number. Today we're looking at graphing results, so we're going to let our calculator do our work for us. There is a factorization theorem. It says that every polynomial has a unique factorization, and there are 2 important points. Every polynomial can be written as a product of its factors and a leading coefficient. So here are all my factors and a leading coefficient. And every polynomial function has the same number of factors as its degree. The factors may be real, complex, and they may be repeated. We're going to start with the coefficient c being either positive or -1, and then we will consider other leading coefficients. Please graph class example 1. I'll adjust the volume a little bit. So we're pretty comfortable getting a graph happening on our calculators. Set your window to the window settings of this graph, -5 to 5 and maybe 10 to 10. It doesn't go up, it doesn't go down quite as low. But -5 to 5 for sure on the x-axis, and from -5 to 10 on the y-axis, that would be good. We can actually read the zeros off the polynomial off the graph. We see that the graph crosses the x-axis at -2, at 1, and at 3. And those would translate into factors of x plus 2, x minus 1, and x minus 3. We're very accustomed to doing that. Now, the only thing we have to check is, does it make sense that these factors would actually multiply to generate my original polynomial? So my polynomial, x plus 2, x minus 1, x minus 3. I'm going to check out, do I get the constant? The constant is plus 6. So 2 times -1 times -3 is positive 6. And I have an x cubed. X times x times x is x cubed. In this case, I want to start identifying what my c value is. That's going to be something that complicates us. Our c value in this case is 1. Really, I don't need to record that, but we will need to take that into account for the next one. Let's turn the page. All right, I'm going to graph this on my calculator and draw a sketch of it. I want to pay particular attention to where the graph crosses on the x-axis. And I see that my graph crosses at -2, at 1, and at 5. And I want to follow those points. These are my x-intercepts. I come down through -2, I come up through 1, and then come down through 5. This is just a sketch, but I want to make sure that I include the arrows which indicate that the graph continues to infinity in both the -x and the positive x direction. So my x-intercepts are -2, 1, and 5. But when I convert those into factors, I've got a problem. And you're going to help me identify that problem. I need to check out what my constant value is and what my leading coefficient is. 2 times -1 times -5 is actually plus 10, and I have a -10. And I also noticed that I have x times x times x, which is x cubed, but I have -x cubed in my polynomial. So here's where I have to identify my c value as -1. And I make that decision based on the polynomial that I'm looking at. Now, what is the left arm of the graph doing? What is the right arm of the graph doing? A little bit of a different analysis. The left arm of the graph is continuing to rise. The right arm of the graph is continuing to fall. This was an odd polynomial. It had an odd degree, and the leading coefficient is negative. In this lesson, we're going to be looking to make some relationships between what the arms of the graph are doing, the degree of the polynomial, and whether the leading coefficient of the polynomial is positive or negative. That's actually it for lesson 7. Make sure you follow the assignment, and lesson 8 is coming up.